And this is a double replacement reaction. And what happens in double replacement reaction is, this is an ionic compound, an ionic compound, ionic compound. So ionic compound means it has positive charge, negative charge, positive charge, negative charge, positive, negative, positive, negative. So double replacement reaction, just by the name, when they react together, so AB and CD, this A switches the partner, which is the anion, the negative charge, it switches. So instead of B, it takes D and becomes AD. It cannot switch with C because it has to be, because its partner is negative, so the other partner that it chooses has to be negative again. So positive can be replaced by positive ion and negative ion can be replaced by negative ion. You cannot replace positive ion by positive, negative ion and negative ion by positive ion. Positive ion is replaced by positive and negative is replaced by negative. So that is called a double replacement. There is a single replacement where only one is replaced, that you will watch the video, but this is a double replacement, so two of those are replaced. So A is positive, B is negative. Instead of B negative, it takes the D. So switch the partner. Similarly, this C is positive and D is negative. Instead of D negative, it takes B. So that's how they switch the partner. So get a little bit bigger. So this is positive, negative, positive, negative, and positive bonds with negative, positive, and negative. So this is positive, negative, positive, negative. Make sense? Yes? Okay. So that's the double replacement reaction. So in this exercise, what you will do is you will apply whatever you have learned until now, meaning you know how to write names of the reactant and predict the names of the product, and going to write a chart above each of the names. The first step. Second step is going to write a formula and write a product. And then number 30 is you're going to write a full balance chemical equation. So that's what you will do. So this one is given. When we look at this, what do you see here? It's silver nitrate. So going to write the name. You should know how to write a name. So this is nitrate, comes from nitrate. This is nitrate ion. So this is nitrate, silver. So it is silver nitrate, okay? And plus sodium chloride. And if you forgot how to name, go back to the ionic compound and refresh. You need to refresh those if you have forgot those, sodium and chloride. And now you are going to predict the names of the product. How do you predict the name? So as we said, A, B plus CD gives positive, negative, positive, negative. AD plus CB, right? Positive, negative, positive, negative. So they just switch the partner. So silver nitrate, sodium chloride, it will be silver chloride and sodium nitrate. Make sense? Okay, so that's what you're going to write in the product side. Silver chloride and sodium nitrate. So once you know the name, then you can easily write a chemical formula. Before you write a chemical formula, what do you need to know? You need to know how to find the chars. So silver, you can go back to the periodic table and look at the chars. Silver has +1 charge. Nitrate is a polyatomic ion. And you can look at the chart, polyatomic ion chart. It has 1 negative charge. So you can write positive here and negative here. 1 positive charge, 1 negative charge, and you know that overall charge of this molecule has to be 0. Yes, so +1 and -1 makes it 0. So that means it's correct. Similarly, sodium has 1 positive charge, chloride ion has 1 negative charge. So once you know the charge of this, you can easily find the charge of these because it's going to be the same charge. Now, once you are done with that, then you can easily write the chemical formula. If you know the charge, it's crisscross. Do you remember or not? AzCl, negative, negative. The charge goes here and goes here, and your formula is AgCl, right? So similarly, sodium here, nitrate here, positive, this is positive and negative, 1 and 1. This one goes over here, that one goes over here. So it is NaNO3. That's what you're going to write, okay? And the net ionic equation, you will know how to do it after you watch the video. Otherwise, I will, if you still have confusion, I will talk about it in our next class. But then after this, then what do you do is, now you are going to balance the reaction. Do you think you can do it? And you're going to do the same for each of these. And what I want you to do is, you do not have to do all of these, but at least do 7, 8 of those, so that if you have any questions like that, and you're even like sapling, or if you have to write an equation, you know how to write it. So this is basically what you have learned from the very beginning of the class up to now. You are using all of your knowledge right here. If you can do this, then that means whatever you have studied until now, you understood. There's another example here. If you look at the example, the same thing. So it says PbNO3 2. So you need to find out the charges for this. Write down the charge, right? First, you need to write the name, and then you're going to figure out the product. And the product is always the exchange, the partner. So lead with sulfate and nitrate, sodium with the nitrate. So lead sulfate and sodium nitrate. Write down the charge. And once you know the charge, the crisscross rule, you can find the chemical formula. Once you have the chemical formula, you can write the whole equation and then balance the equation at the end. Okay, I want you guys to try these. So can anybody tell me what would be, this is double displacement reaction or double replacement reaction. So what would be the answer? What would be the product in double replacement reaction? They switch the partner. Can anybody tell me? You can speak.
Barium carbonate.
Barium carbonate.
Potassium
Potassium chloride, yes. So barium carbonate and potassium chloride, right? So now the next step is to find out the oxidation number or the charges which goes on the top over here. So when you look at this, it is K2CO3. Can you go to your ionic periodic table and figure out what is the charges? What are the charges for potassium here, and what is the charge for carbonate? Anybody? Charge for potassium, you can look at the periodic table, the ionic, so which you can find in your lecture notes, second page or third page. If you can speak, would be great. For potassium, what is the charge for potassium?
Is it 1+?
Right, good. And for carbonate? So if you know that is 1+, the other thing how you can find is this is a carbonate, so it is CO3. So if this has, you can see 2 here, that means the carbonate has
2-.
2-. Okay? And always make sure you write the number first and then only the charge, not the other way around. You do not write this. Not like this, but like this. Okay? Now the barium and chloride. What is the charge for barium and chloride? Barium is +1 or 2?
2.
2. So if barium is +2, so you have barium and chloride. So chlorine would be what? Because you know the crisscross method, it is?
-1.
-1. Okay. So if this is the charge over here, the same charge will apply to the other side. The charges will be the same. So if the barium is 1, 2+, we can write 2+ here. Carbonate is 2-, we can write 2-. Potassium is 1+, 1+. Chloride is 1-, you can write 1- over here. Okay? So now you have this portion already done for you. Now you need to figure out this portion. If you have everything here, the charges, it's easy to write a chemical formula by looking at these charges. How do I write barium carbonate? Barium and carbonate. Do I have to write any subscript or no for barium and carbonate?
No.
No, actually it would be 2 and 2, but those 2 and 2 cancels out. So we do not have to show the 2 and 2. So we are good with just this much, right? And for potassium chloride, charge is 1 and 1. So how do I write? This is potassium, this is chloride. Do I have to write any subscript?
No.
No, because it is 1 and 1. Are you guys following me or not? All of you. Okay, good. So now we have the complete reaction. So it is what? K2CO3 plus barium chloride will give barium carbonate plus potassium chloride. And now the next step is to balance the reaction, which you know how to do it. If I put 2 here, then it is balanced, okay? Now my next step is to find the net ionic equation. And as you know, the net ionic equation is the 1 if during the reaction, on the reaction side and the product side, if the species stays the same, then those cancels out. We do not have to show, and we will show only the one which changes. So that's what we are looking at. So for that, what we need to find is whether these are both soluble, these are all in aqueous state, and what we need to figure out is, out of these two products, do they form precipitate or not? So I want you guys to go to your chart. So one is barium carbonate and the other one is potassium chloride. Let's go back to the chart and figure out. Can you guys figure that out? So go back to your solubility chart. Okay, now, so it is barium carbonate. So look over here, where is barium is right here, right? So we have barium here and carbonate is right here. Do you think it is it soluble or insoluble? Barium carbonate. Soluble or insoluble? Insoluble, yes. How do you figure it out? So you just go down here, barium and the carbonate, it's over here. So the black one, it is insoluble. So what do we write here then? If it's insoluble, then you're going to write over here, it is going to be solid. Okay? Now potassium chloride, look at potassium chloride. Potassium here, chloride here. Is it soluble or insoluble? Cynthia, which one did you say is insoluble? Barium carbonate is insoluble. Okay, and this is soluble. Okay. And this is soluble. So this has to be in aqueous form then. So now let's go back over here. Okay, so we have these two. This is solid and this is aqueous. So we do not have to show the aqueous one. We only have to show the solid one for the net ionic equation, because we're just going to show the precipitated one. So to form potassium chloride, so the next step, what you can do is this. So two ways you can do. Either you can just simply write barium carbonate over here, which is solid. And what do you need for the barium carbonate? How does barium carbonate form? It is formed by barium. And what charge does barium has? Charge, positive 2 charge, yes?
Yeah.
Okay, so you can just write barium with 2 positive charges, and it's aqueous, plus, and then we have carbonate over here. We get carbonate from here. What is the charge for carbonate? It is again, comes from here, and it is -2. So carbonate with -2. So this is going to be your net ionic equation. So this is one way of doing it, and this is easy. Just look for the solid, the precipitated part of the product side, and look for how this is formed, which one. So like barium, where did you get barium from? And what is the charge for the barium? And the carbonate, where did you get carbonate from? And what is the charge for the carbonate? So that is one way of doing it. And the other way would be to write everything down and cancel, cancel, cancel. And so that's just going to be one more step, which is going to be K positive plus, so if you write the ionic equation for all of those, you will have K positive plus CO3, 2 negative. This is 1 positive. Plus for barium chloride, you will have barium 2 positive plus carbonate 2 negative, and it will give barium carbonate plus potassium plus and Cl negative. You can do it either this way and then cancel the potassium. Here is chloride. This is not. Chloride, and write these two down, or you can just do this step. So whichever is easy, follow that step.